Everybody, today we're going to be going over combining the last three projects and doing real-time video capture, GPS capture, and also IMU streaming utilizing GPO pins from our Raspberry Pi to our Arduino and putting them all together and doing it in real time. So again, we're using the Q&Out DIY drone and really we're just trying to get that real-time video feed, GPS, and then IMU data through a socket as well. So let's continue on and look at our requirements. First requirement, we have to assemble it, calibrate it, and demonstrate some hovering of the drone. Then we're going to show some pitch, yaw, and roll. Requirement 7, FAA registration, that's always important. And then we're going to attach our video camera to our drone, Raspberry Pi to the drone, attach our Arduino with the IMU sensor to the drone, and then configure local Wi-Fi for the host machine and Raspberry Pi. And then from there, we're going to connect our Raspberry Pi to our camera, GPS device, make it streamable, and then connect our Raspberry Pi to our Arduino, and then connect our configure our Arduino to display that IMU data to host. And then for this last one, we're utilizing GPIO pins for communicating between the Arduino and Raspberry Pi. So if you want to see how we built out the drone, I would refer you to the past two videos. But let's look at what has changed. So the big thing that has changed is actually how we're powering our components now. So I noticed that I wasn't getting enough amperage through my battery to the power module and then finally to the buck converter. And then taking from that buck converter to the Raspberry Pi. This was causing a lot of brownouts, and from experience with the past two projects, I can say that that's probably why I had some rougher Wi-Fi on the Raspberry Pi, and which was leading to actual video feed stuttering. That's since been fixed since we've added an external battery, and that can be viewed right here. So we actually have our external battery, we have our Raspberry Pi, we have a little installation right here, and then we have our Arduino on top. And we're using a CDO seed LoRaWAN Arduino board. And then from there, we actually have it connected over SDA and SCL to the slave SDA and SCL on the Raspberry Pi. So then our Arduino can push the commands to push the data to the Raspberry Pi versus the Raspberry Pi querying for the data. Just makes it a little bit quicker and it was a little easier to implement. And then we are also powering our Arduino through our Raspberry Pi via the 3v3 and grounding pins. So our data, our Arduino code didn't really change all that much. We did move from RTOS to a normal setup loop kind of functionality. And really, we took out the tasks and moved that into the loop function. And then we added transmissions for the X, Y, and Z IMU datas, which are then read from the host. So going forth, the other major difference was that we are now utilizing Pi GPIOD. This is a Python library for handling GPIO pins on the Raspberry Pi specifically, and it allowed me to actually set up the Raspberry Pi as a slave device to the master Arduino device. So once we actually installed that, we then have our drone sensor suite GitHub repo, and from there we're able to navigate into the IMU reader GPIO folder and then run that main Pi GPIOD py file. To get that data over to the host, we have a host machine client Python file which connects it over a socket, and then all we do is run python host machine client.py. Now to look at the results, again we have our same VLC from our last video, or our last documentation. We have our GPSD data which is being sent via Telnet, and then what's new is we have our IMU socket from the Raspberry Pi, correct this right here, to the host machine. And then we can see it all on one screen right here. We have our GPS in the top left, our IMU data in the bottom left, and then on the right side we have our VLC client with the video streaming. So that is the overview. Next we'll actually go through configuring and setting up the Raspberry Pi. So once I have SSH into the machine, I'm going to go ahead and start Pi GPIOD. this should already be running, hence why we can't initialize it, but that's what I would do. The next thing I'm going to do is do docker compose up -d for our video RTSP and then our GPSD. This will start up both those services. Again, they're already up and running. And then now we're going to go ahead and go into our IMU reader, which is using GPIO pins. And we're going to go ahead and run that main file, Python file in there. And this is really just setting up the Raspberry Pi as the slave to the Arduino over I2C. So next, let's go ahead and configure get our host machine up and running. So the first thing I do is I have that Python script in our downloads. So actually we already have it over here. So Python host machine client, it's also in that GitHub under the host machine folder. So let's go ahead and then we can see that's actually giving us some results. If we move it around, we can see those actual IMU data change. And then from forward, we can add our GPSD. So let's telnet to get that data from GPSD from the Raspberry Pi. So we put in our IP. There we go. Oop. 2947. So IP and then the port. And then we put in our watch command. And now this is pulling that latitude, longitude, and altitude. So next, let's configure our video. So if we go to File, Open Network, this is just set up as the IP of the Raspberry Pi and then connected to that PiCam. So I figured out the problem. The problem was that the video interface actually got assigned to /dev video 1 instead of dev video 0. So I just restarted the Raspberry Pi and followed the same steps. And now we can see that we have GPS on the right, our IMU data coming from the Python host machine script from the Raspberry Pi on the left. And then we can see we have our video here. If we wave our hand in front of it, there's a little delay, but looks all good. The next thing I'll show is the actual test flight. So now we're going to watch some video of the two different flights. The first one's very unspectacular. We are pretty much starting it up right here, and then we're immediately going to flip it over. But we can see that we are having our IMU data coming across correctly. We have our GPSD in that top left-hand corner, IMU in the bottom left-hand corner, and then we have our video on the right-hand side. The other thing we can see is, and now I'm actually taking it to a better spot, we can see those values change as the drone moves, which is always important. So now we're going to go for our flight number 2. This one gets a little bit more height before we come crashing down because of my spectacular drone flying skills. But that'll wrap up this project. Thank you guys for watching, and I hope to see you next time.